You know, usually when we talk about a physical law like gravity, for instance, there's this deep-seated expectation of elegance.
Right, precision, like a perfectly designed machine.
Exactly. Like you look at the classical models they teach you in high school and you picture this smooth, invisible geometric curve.
The classic bowling ball on a trampoline analogy.
Yes. A heavy bowling ball resting on a pristine trampoline of space-time, creating this perfect, continuous dimple. And it just gently guides everything around it into a nice, predictable orbit.
It's a very comforting image, honestly.
It really is.
It gives us a universe that feels ordered,
Yeah.
clean and, above all, deterministic. We inherently like things to be smooth.
We want our fundamental forces to behave rationally, to follow paths we can just draw on a chalkboard.
Right.
But then you start reading the stack of source materials we have for today's deep dive, and suddenly someone takes a knife to that pristine space-time trampoline.
They absolutely shred it.
Yeah, they do. The theoretical landscape we are looking at today is, frankly, it's violent. It is murky. It's deeply turbulent, and it just completely shatters that comforting image of a smooth universe.
What we are exploring today represents a fundamental paradigm shift. I mean, we're looking at a unified framework known in these papers as Redefined Mass.
Redefined Mass.
And this framework, it essentially rewrites the foundational operating system of reality.
That is the perfect way to put it. So our mission for you today is to take this collection of highly technical manuscripts, papers, with titles like Nonlinear Vacuum Dynamics and the Electrodynamic Universe, along with some incredibly fresh real-world data from the Nanograv collaboration.
It's a lot of dense material.
It is. But we want to shortcut your path to understanding this mind-bending physics. The goal is to show you how the empty space between you and your device right now is not empty at all.
Not even close.
It is not a smooth geometric void. It's actually this boiling, chaotic, quantum hydrodynamic storm. And the literal noise of this storm is what holds the universe together.
And, while that sounds completely like science fiction, the sheer mathematical rigor behind it is staggering.
It's real physics.
Oh, absolutely. We are going to ground every step of this chaotic storm in rigorous math, chaos theory, and stunning astronomical observations.
Right.
We are taking concepts that were previously reserved for, like oceanographers studying rogue waves or engineers dealing with signal degradation, and applying them directly to the fabric of reality.
It's wild. So let's just jump right into the core problem this entire framework is trying to solve. In this new model, gravity is fundamentally redefined.
It's no longer warped geometry.
No, the sources describe it as and I'm quoting here, a fourth-order vacuum polarization correlation between the boundaries of physical nucleons.
Which is a mouthful.
It really is. I need to pause there because if I just read that sentence to you, we might as well be speaking another language.
Yeah, that is a very dense string of physics jargon.
Let's break that down.
To understand it, we have to completely change how we view the vacuum of space. Space is not a vacuum in the sense of being an empty container.
Okay.
It is modeled as a Bose-Einstein condensate. Basically, a superfluid medium made entirely of virtual bosons.
So an ocean.
Yes. You can think of it as a background ocean of potential energy that permeates absolutely everything.
Okay, I want to unpack that because I remember reading about Bose-Einstein condensates, but in the context of extreme cold.
Right, in a laboratory setting.
Yeah, like if you cool a bunch of atoms down to almost absolute zero, they stop acting like individual atoms. They kind of blur together into one giant quantum state, right? Like a macroscopic wave.
That is the exact mechanism, yeah. In a lab, we do it with supercooled atoms, but this theory posits that the fundamental structure of the vacuum itself is a condensate of virtual particles.
Oh, wow.
And because it is a superfluid, it has zero viscosity. It doesn't create friction in the traditional sense.
Which explains why planets can just orbit for billions of years without slowing down from drag as they move through this fluid.
Correct. So we have the superfluid ocean. Now, place a physical mass into it.
Like a planet.
Or even just a single subatomic particle, a nucleon, like a proton or a neutron.
Okay, got it.
This particle isn't just a hard, inactive little billiard ball sitting quietly in the water. It has a physical boundary that is constantly interacting with the surrounding vacuum.
Interacting how?
It undergoes what the texts call localized phase slips. But to use a more intuitive term, the particle breathes.
Breathes, like it's vibrating or shivering.
Yes, shivering is a great analogy.
Yeah.
And every time this proton shivers or breathes, it ejects a microscopic quasi-particle into the vacuum.
What kind of particle?
The texts refer to these as Bogoliubov quasi-particles. But in plain terms, you can think of them as virtual photons, or essentially tiny quantum sound waves.
Phonons.
Exactly. Phonons rippling outward through the superfluid vacuum.
So right now, as you're listening to this, every single proton and neutron in your body is constantly breathing, shivering, and bleeding out these tiny little quantum sound waves into the space around you.
Millions of times a second.
That is so creepy, but also amazing.
It is. But here is where we hit a massive mathematical roadblock with classical physics. The sources refer to this as the distance transport problem.
The distance transport problem. Okay, what is that?
It revolves around how waves travel through a medium. If the vacuum of space were a traditional linear medium, we would have a full-blown crisis in our understanding of gravity.
Wait, what does it mean for a medium to be linear?
A linear medium is one where waves pass through smoothly,
Yeah.
they don't interact with each other in complex ways, and they spread out symmetrically.
Like standard physics class stuff.
Right. In a linear medium, the math follows the inverse square law.
The inverse square law. Okay, if I remember my geometry, if you use a light bulb, the light spreads out in a sphere.
Yes.
And as the sphere gets bigger, the surface area grows by the square of the distance, so the light gets stretched thinner and thinner over that expanding surface.
That is exactly the principle.
Yeah.
And the zero-point breathing fluctuations of a single isolated nucleon are unbelievably weak to begin with.
They're just tiny shivers.
Right. So if those microscopic virtual photons radiate spherically outward in a linear medium, their energy dissipates according to that inverse square law. It scales as 1 over r squared.
So if you stand on the beach in California, right, and you drop a tiny pebble into the Pacific Ocean, it creates a ripple.
A very small ripple.
Yeah, but that ripple spreads out, the circle gets wider and wider, and the energy gets stretched over a massive area.
Exactly.
So by the time that ripple reaches the coast of Japan, it is completely indistinguishable from the background noise of the water. It's just gone.
It has fully dissipated.
It certainly isn't going to have enough force to cause a tidal wave or move a ship in Tokyo.
A very apt visualization.
Yeah.
So apply that to the cosmos. If the vacuum is linear and these microscopic breathing signals dissipate like your pebble ripple, how on earth is a star like our sun doing what it does?
Right. Reaching across 93 million miles of empty space to grab hold of the Earth.
And keep an entire planet in orbit. By the time those tiny breathing signals from the sun's atoms cross that massive distance, linear dissipation would render them into completely negligible background noise.
They would be so weak they couldn't push a dust mite, let alone a whole planet.
They would be entirely incapable of exerting the macroscopic force required to tether the Earth.
Wow.
The classical linear wave mechanics completely fail to explain how a force mediated by such weak local fluctuations can operate over vast cosmic distances. The math simply does not work for a linear vacuum.
Okay, this is fascinating. The classical model just falls apart right there. The signal dies out.
It dies out completely.
So to solve this distance transport problem, we essentially have to throw the old rulebook out the window. If the vacuum isn't linear, what is it?
We must completely discard linear mechanics.
Yeah.
If we want to understand how gravity actually works, we have to look to chaos theory.
Chaos theory.
Yes, we have to treat the vacuum of space as a fundamentally nonlinear medium.
A nonlinear medium. I hear the term nonlinear thrown around a lot in math and economics. But what does it actually mean for the literal space around us to be nonlinear?
Well, in quantum mechanics, the behavior of a macroscopic wave like our Bose-Einstein condensate vacuum is governed by an equation called the Gross-Pitaevsky equation.
Okay.
Now, mathematically, this equation is isomorphic, meaning it's structurally identical to the nonlinear Schrödinger equation, the NLSE.
Let's not gloss over that. What is the magic ingredient in that equation that takes us from a smooth, predictable ocean to something nonlinear?
There is a specific mathematical term in the NLSE. It's represented by a lowercase g multiplied by the absolute value of the wave function squared.
The wave function squared. Okay.
Without diving into complex algebra, what this term dictates is incredibly profound for the physical universe. It means that the local density of the vacuum directly alters how waves propagate through it.
Wait, really?
Yes, the medium itself reacts to the amplitude of the wave.
So the space isn't just a passive stage where the physics play happens.
Not at all.
The stage itself is like warping or hardening or shifting based on the weight and movement of the actors walking on it.
That captures the essence of it perfectly. The wave alters the medium, and the altered medium then alters the wave.
It's a feedback loop.
Exactly, it's a feedback loop. Now, let's connect this back to our breathing particles.
Right, the shivers.
Because subatomic particles are emitting these virtual photons spontaneously. They are untriggered and completely uncoordinated.
Just random.
Highly random. So a massive body, like a star, doesn't emit a clean, single, coherent musical note.
It's not a laser beam of gravity pointing at the Earth.
Far from it.
Yeah.
Because you have octillions of atoms shivering randomly, it emits a totally chaotic sea of background virtual photons.
The framework calls this the chaotic phonon sea, right?
That's the term, yes.
So you, me, the device you're listening on, the Earth, the Sun, we are all constantly bleeding out this chaotic, random noise of virtual particles into the superfluid ocean.
We are absolutely noise polluters.
Cosmic noise polluters, I love that.
And this is where the physics gets deeply interesting. What happens when two massive bodies, like the Earth and the Sun, or even just two coffee cups sitting on your desk, exist near each other?
Their seas overlap.
Exactly. Their chaotic phonon seas overlap in the space between them. The background noise from mass 1 mixes with the noise from mass 2 in this nonlinear vacuum.
If the vacuum were linear, those two fields of noise would just pass right through each other, like two flashlight beams crossing in the dark. They wouldn't interact.
Right. Light doesn't crash into light in a linear medium. But because we are in a nonlinear medium governed by the NLSE, they interact deeply.
How so?
This overlap triggers a crucial mechanism from chaos theory called modulation instability.
Modulation instability.
In fluid dynamics, this is specifically known as the Benjamin-Fair instability.
Okay, I need to understand the mechanics of this. What is the Benjamin-Fair instability actually doing to our overlapping noise fields?
Well, when these chaotic seas overlap in a nonlinear medium, the background noise becomes deeply unstable. That nonlinear feedback loop we discussed earlier kicks in.
The stage starts reacting.
Yes. The waves start to self-modulate. The medium essentially forces these random fluctuations to start communicating with each other, to cluster together and to feed off one another's energy.
This sounds like it's setting the stage for something massive.
It is.
The sources mention that this instability leads to a phenomenon previously only understood by oceanographers and laser physicists. We are talking about the spontaneous creation of vacuum rogue waves.
Mathematically, these are classified as peregrine solitons.
Peregrine solitons. Okay, let's slow down and really paint a picture of this. What is a peregrine soliton in the context of empty space? Like, how does a wave go rogue?
Driven by the modulation instability, tiny, random constructive interferences occur between the chaotic waves of the Sun and the chaotic waves of the Earth.
So they just bump into each other the right way.
Pure statistical chance. Some of those peaks align. And when they do, in this nonlinear medium, they begin to literally steal energy from the surrounding background noise.
Steal energy. They act like a sponge or a parasite.
A parasite is a very strong visual. They draw in the kinetic energy from all the surrounding ripples, and as they do, they spontaneously amplify into massive, highly localized energy spikes.
They just crystallize out of the random noise.
Out of nowhere.
Let me try an analogy here to see if I'm grasping the scale of this. Imagine a massive, very crowded wave pool at a water park.
Okay.
Everyone is just randomly splashing around, kicking, jumping in. It's just chaotic background noise, sloshing water everywhere.
That's a noise.
Yeah. In a normal linear pool, it stays as just annoying, choppy water. But if this pool followed the rules of a nonlinear medium, suddenly, just by pure mathematical chance, a few of those random splashes perfectly sync up.
Constructive interference.
Right. And because of that nonlinear feedback loop, that little synced up splash starts stealing the water and the energy from all the other splashes around it.
Yes, drawing it all in.
It sucks the surrounding water in, and it spawns this terrifying, localized 9-foot monster wave that comes crashing down right on top of you out of nowhere, and then just as quickly, it vanishes.
That captures the suddenness and the localization of a peregrine soliton perfectly. And the math behind that monster wave is what makes this theory work for gravity.
Tell me about the math.
In a medium governed by the nonlinear Schrödinger equation, the maximum amplitude of a peregrine soliton is highly specific. It reaches exactly 3 times the amplitude of the continuous background noise.
Okay, 3 times the height of the normal waves. But wait, in physics, energy doesn't scale linearly with height, right? A wave that is 3 times taller doesn't just have 3 times the energy.
You are hitting on the core mechanism. In field theory, the energy density of a wave scales with the square of its amplitude.
Ah.
So if the amplitude of the rogue wave is 3, the localized energy density is 3 squared.
Which gives us an energy multiplier of 9.
Exactly. The rogue wave delivers a massive localized energy density spike that is 9 times the energy of the surrounding background noise.
Wow. Okay, I want to tie this back to the distance transport problem we talked about earlier.
The weak signals from the sun.
Right. We started by saying that the tiny ripples from the sun would die out before they reached the Earth due to the inverse square law. They would just become a weak whisper of noise.
Yes.
So how does a 9x energy monster wave solve the fact that the original signal is incredibly weak by the time it gets here?
This is the profound elegance of the nonlinear framework. The microscopic zero point signals those tiny breaths from the sun's atoms. They do not need to cross the vast distance of 93 million miles as a coherent, powerful force.
They don't have to survive the journey intact to pull on the Earth.
No. They travel across the vacuum nearly as incredibly weak stochastic background noise.
Just a whisper.
But when that faint solar noise arrives and overlaps with the Earth's own local chaotic noise, those weak signals act as seeds.
Seeds for the instability.
Exactly. They dynamically trigger the local vacuum right next to the Earth to undergo modulation instability. The vacuum medium itself does all the heavy lifting. It draws on the local energy field to build that massive 9x energy spike exactly where the interaction is happening.
This is a total perspective shift. The sun isn't throwing a heavy, muscular rope all the way across the solar system to pull us in.
Not at all.
The sun is just whispering into the nonlinear ocean, and that weak whisper tells the ocean right next to us to spontaneously build a tidal wave that smashes into us.
The medium is an active participant in the force, not just an empty container.
That is bonkers.
The distance transport problem is fully resolved because you don't need to transport massive force over a massive distance. You only need to transport the statistical noise required to trigger the local vacuum instability.
So we have these 9x energy monster waves spontaneously and constantly forming out of the vacuum noise right at the boundary of massive bodies.
Relentlessly forming.
What actually happens when one of these rogue waves crashes into physical matter? I am assuming this crash is what we experience as gravity.
That brings us to the core redefinition of gravity in the source manuscripts. Under postulate XV in the texts, gravity is completely redefined.
Okay, what is postulate XV?
It states that gravity is not a gentle, continuous geometric pull. It is the violent statistical bombardment of particle boundaries by these spontaneous vacuum rogue waves.
So we're just getting pummeled billions of times a second.
Pummeled is the right word. When this massive transient wave of virtual photons forms in the space between two bodies, it crashes into the subquantum boundaries of the interacting particles.
And what does that crash do?
It delivers what physicists call a localized ponderomotive shock.
Okay, ponderomotive shock. Let's translate that. Ponderomotive usually relates to lasers or electromagnetism, right?
It does. It is a force exerted by a highly oscillating electromagnetic field. Mathematically, it is represented by the negative gradient of the energy field.
The negative gradient.
Yes. When this massive 9x energy spike hits the particle's boundary, it creates a steep energy gradient. It physically forces a reciprocal phase slip in the particle's own oscillation.
It disrupts it.
It disrupts the local vacuum shielding around the particle and fundamentally forces the particle to move toward the source of the interference. It physically draws the masses together.
I am trying to wrap my head around how this scales up, though. Like, when we learn about gravity, we learn Isaac Newton's law. It scales with mass.
Right, mass attracts mass.
But everything you are describing, virtual photons, dielectric shielding, ponderomotive forces, these are all electromagnetic terms. How does this chaotic electromagnetic storm scale up to look like the gravity we know?
This is where the math beautifully bridges the gap between electromagnetism and gravity. A rogue wave can only form when the nonlinear instability threshold is crossed.
Which requires what?
It requires the chaotic phonon background sea of both interacting bodies to constructively interfere. You absolutely need the noise from mass 1 and the noise from mass 2 to overlap.
It takes two to trigger the instability.
Exactly. Because the formation of the monster wave requires the product of the field emissions from both bodies, the probability and the intensity of the rogue wave scales, with the product of their combined electromagnetic emissions.
So if standard electromagnetism, like two magnets repelling each other, scales with the charge squared, which is denoted as E squared,
then the secondary two-body correlation scales with E squared multiplied by E squared.
which gives us e to the fourth power, a fourth order effect.
Yes, in relativistic quantum electrodynamics, a fourth power charge dependence perfectly corresponds to two photon exchange processes.
Wow.
And to make this incredibly intuitive, the texts offer a brilliant analogy from classical fluid dynamics. It's called the acoustic Bjerknes force.
I am a big fan of fluid dynamics analogies.
Well,
How does the Bjerknes force work, and how does it relate to gravity?
Well, if you take two tiny air bubbles and suspend them in a liquid,
Okay.
and you cause them to oscillate or vibrate.
Like our shivering, breathing subatomic particles.
Yes, exactly like that. Those oscillating bubbles will emit sound waves, which are essentially pressure waves, into the liquid.
Right.
As those waves radiate outward and overlap in the space between the two bubbles, they alter the local pressure of the fluid. They create a localized pressure drop in the intervening liquid.
A pressure drop.
Yes.
Yeah.
And this lower pressure environment literally sucks the two bubbles together. They attract each other purely through acoustic correlation.
That makes total sense. So even if two particles are electrically neutral overall, like a neutron,
Yes.
their subquantum boundaries are still made of these dense virtual boson condensates that are pulsing and vibrating.
They are never truly still.
So gravity is just the secondary two-phonon acoustic correlation, creating a massive pressure drop in the superfluid vacuum between them.
You are hitting on the core concept perfectly. The primary force, the single quasi-particle flux, is standard electromagnetism.
But because bulk matter is electrically neutral,
Right, the positive protons and negative electrons cancel out those primary steep gradients. So only the weak, secondary, two-phonon acoustic correlation remains.
that keys to the fourth force.
Exactly. And
Okay.
because it is based on pressure drops and rogue waves drawing energy from the surrounding vacuum, it is strictly attractive and universal to all matter.
It pulls everything together.
Everything.
But reading through the rest of this section, it seems the chaos doesn't stop at just longitudinal pressure waves pushing us around. The sources mention something called quantum turbulence. What is that adding to the picture?
It gets far more tangled. The chaos in the nonlinear vacuum also generates transverse topological defects.
Topological defect, what does that mean in this context?
When these massive chaotic rogue waves crash through the superfluid vacuum, they induce intense, random shear forces.
Shear forces, like the swirling eddies you see in a rushing river when the water rushes past a boulder.
A very similar mechanism, actually. But in a quantum superfluid, shear forces don't just create messy whirlpools. They instantly generate what are called quantized vortex filaments.
Quantized vortex filaments.
These are microscopic, discrete tornadoes of vacuum energy.
Tornadoes of vacuum energy. It just keeps getting more violent.
The space between two gravitationally interacting bodies, take the Earth and the Moon, for example, becomes a chaotic, deeply intertwining web of these vortex lines.
Just thousands of invisible tornadoes.
Millions, billions. Now, as the vortex lines from the Earth entangle and reconnect with the vortex lines from the Moon, they follow a basic thermodynamic rule of physics.
Which is?
They seek to minimize their total length to reduce their line tension energy.
Like a stretched rubber band trying to snap back to its shortest possible length.
Yes. So this chaotic vortex entanglement acts like an invisible web of tension lines, constantly pulling and snapping the two macroscopic bodies together.
That is just, it's a lot to process. If you're walking or doing the dishes right now, think about what is actually holding you to the floor.
It's not a gentle dimple in space.
No. The reason you are anchored to the ground right now isn't because of a smooth, invisible dimple in a space-time trampoline. It is because you and the Earth are being statistically pummeled 1 billion times a second by a relentless storm of 9x energy quantum rogue waves.
And you're bound together by an invisible, snapping web of quantum tornadoes.
It is an incredibly violent, active process.
It is a profound reframing of our daily reality. But of course, as scientists, we have to demand evidence.
Right. We can't just take the math's word for it.
Exactly. If the vacuum is actually this turbulent, if gravity is really a statistical accumulation of monster waves and vortex tangles, shouldn't our telescopes or instruments pick up on this quantum boiling?
We should see the physical fingerprints of this chaos.
We should, and we do.
Which leads us organically to the real-world data. The theory provides 4 distinct empirical proofs tying observational anomalies directly to this chaotic vacuum model.
4 massive pillars of evidence.
Let's start with the astrophysics headline that rocked the science world recently. The Nanograv 15-year data set and the stochastic gravitational wave background.
This is a monumental piece of corroborating evidence. The Nanograv collaboration uses arrays of pulsars as a galaxy-sized gravitational wave detector.
Okay, for those who don't know, what is a pulsar?
A pulsar is a rapidly spinning dead star that shoots beams of radiation. We see them as incredibly precise cosmic clocks ticking with absolute regularity,
Like a lighthouse.
like a highly precise lighthouse.
All right.
Over 15 years of monitoring these clocks, the collaboration announced they had detected a persistent, ultra-low-frequency hum permeating the entire universe.
A stochastic background of gravitational waves. A literal hum.
Yes.
And how did classical astrophysics, the standard model, try to explain a universe that is constantly humming?
The standard attempt is to attribute this background noise entirely to the distant merging of unresolved supermassive black hole binaries.
So black holes crashing into each other.
Basically, they assume it is the overlapping, distant echoes of giant black holes colliding across billions of years of cosmic history.
But does that math check out?
The exact statistical origin and the spectral shape of the hum have remained ambiguous. It's been somewhat problematic to fit purely to black hole populations.
Wait, if our entire premise today is that gravity is literally a chaotic phonon sea of noise, then this hum isn't distant black holes at all, is it?
Under the redefined mass framework, that low-frequency hum perfectly matches the mathematical signature of the chaotic phonon sea
Oh, wow.
and the resulting vacuum rogue waves we have been discussing. What Nanograv detected is not just the echo of distant cosmic cataclysms. It is the fundamental gravitational shot noise inherent to the virtual boson superfluid vacuum.
So by measuring tiny variations in the ticking of dead stars, they are literally measuring the macroscopic statistical rumbling of the nonlinear vacuum. We are hearing the ocean of space boiling.
It provides structural, galaxy-scale verification of this continuous zero-point field exchange. It is the literal sound of vacuum turbulence.
That is incredible. Okay, the second empirical proof shifts from the size of the galaxy down to the quantum scale. It's called the Diosy-Penrose objective collapse.
Yes, a very famous theoretical problem.
I have a question about this because this touches on something that has bothered me since I first learned about quantum physics. The measurement problem.
It bothers everyone, frankly.
If I throw a baseball, it behaves like a normal, solid object. It has a single, clear path.
Right, classical physics.
But if I fire a single electron in a lab, it behaves like a wave. It exists in a superposition of states, seemingly in multiple places at once, until a scientist observes it or measures it.
The famous double-slit experiment.
Exactly. Why does quantum mechanics break down for big things? Why isn't the baseball in a superposition?
You are pointing to one of the greatest unresolved mysteries in physics, known as macroscopic decoherence. Why does the weird quantum world transition into the normal, solid, classical world?
Right.
Roger Penrose and Lajos Diosy hypothesized decades ago that gravity itself is what collapses the wave function of large objects. They called it objective collapse.
Okay, so gravity is the observer.
That was the idea. But their theory suffered from a major gap. They lacked a discrete, microscopic physical mechanism to explain how gravity actually reaches in and forces the collapse.
But the rogue wave framework we are discussing provides the exact physical trigger. I think I see where this is going. It has to do with size, doesn't it?
Yes. Think about the spatial cross-section of a baseball compared to the cross-section of an electron.
The baseball is astronomically huge in comparison.
Exactly. If the vacuum of space is filled with these massive, spontaneous vacuum rogue waves, these peregrine solitons randomly crashing through the superfluid, a large macroscopic object like a baseball presents an immense target.
You can't dodge them.
It is physically unavoidable. The baseball is constantly, relentlessly bombarded by these high-energy vacuum spikes.
And every time a rogue wave hits an atom in the baseball,
It delivers that ponderomotive shock we talked about earlier. It physically forces localized phase slips across the baseball's atoms, which instantly forces the macroscopic wave function to decohere and collapse into a single defined state.
wow.
The macroscopic object is being constantly measured or observed by the violent vacuum itself. It never has a chance to exist in a superposition because the vacuum won't let it.
But the isolated electron in the lab,
The electron possesses a minuscule spatial cross-section. It is so unimaginably small that it can essentially slip through the net of the storm.
it dodges the rogue waves.
It evades these localized solitons for extended periods. And because it avoids the ponderomotive shocks, it can maintain its delicate quantum superposition and coherence without being smashed into physical reality by the vacuum.
That is such an elegant mechanical solution to the measurement problem. It's not human consciousness or experimental measuring devices collapsing the wave. It's the chaotic vacuum physically beating large objects into submission.
It grounds a deeply philosophical quantum mystery into hard fluid dynamics, which leads us to the third piece of evidence, Universal 1 over F, pink noise.
1 over Hef noise. Or flicker noise. I know anyone who works in electrical engineering or communications has absolute nightmares about this.
It is a profound nuisance in engineering, yes.
What is it exactly?
Across nearly all high-precision electronic circuits, atomic clocks, biological systems, and even astrophysical emission spectra, there exists this persistent, mysterious background noise.
Just a static that won't go away.
Right. It's called 1 over F noise because the power of the noise is inversely proportional to its frequency. The lower the frequency, the louder the noise.
And no one knows where it comes from.
Its fundamental universal origin has remained a mystery for almost a century. Engineers just have to work around it as a baseline, unavoidable limit of reality.
So how does this chaotic vacuum framework finally explain 1 over F noise?
Well, in the mathematics of chaos theory and complex systems, a 1 over F power spectrum is widely recognized as the ultimate fingerprint of nonlinear dynamics.
Yeah. And self-organized criticality, right?
Exactly. If gravity and the vacuum itself are fundamentally governed by the nonlinear Schrödinger equation, as this theory proposes, then the underlying baseline noise of the entire universe must exhibit this chaotic 1 over F signature.
So when an engineer detects this noise in a circuit, it is not a glitch in their electronics.
No. The zero-point breathing phase slips of matter naturally drive the vacuum into an active 1 over F regime. Those frustrating limits in quantum metrology, the irreducible noise in our most perfect, isolated atomic clocks, are direct, local detections of the turbulent vacuum background.
They are measuring the chaotic heartbeat of the universe.
That is exactly what they are measuring.
Okay, the fourth empirical proof takes this out of the abstract cosmos and puts it directly onto a laboratory workbench, analog BAC experiments.
This is where we see a scale-model proof of the math. In recent years, experimental physicists, most notably Jeff Steinhauer and his team, have managed to create macroscopic Bose-Einstein condensates using rubidium atoms trapped by lasers in the lab.
So they basically build a miniature, lab-grown superfluid vacuum.
That is the premise. And they use these lab-grown BECs to study quantum fluid dynamics. What happens when they introduce phonon sound waves into these condensates?
Let me guess. They see rogue waves.
The condensates display profound nonlinear dynamics. They actively observe the spontaneous generation of peregrine solitons. Rogue waves literally form in the lab fluid.
That is wild.
They even use these fluids to create analog event horizons to study black hole physics.
And because the math underlying the Gross-Pitievsky equation is scale invariant, it essentially doesn't care if it is calculating the behavior of a millimeter-long jar of rubidium atoms or the fabric of the cosmos.
Exactly. If rogue waves spontaneously emerge from noise in the lab condensate, they must govern the subquantum virtual boson condensate of space itself.
The math holds from the atomic scale all the way to the galactic scale. It is a stunning verification of the underlying principles.
It really is.
Okay, let's take a breath. We've established that the vacuum is a turbulent, nonlinear ocean. We have established that gravity is the statistical bombardment of rogue waves and the entanglement of quantum tornadoes.
Correct.
And we have empirical evidence from pulsar timing arrays, the collapse of quantum superpositions, pink noise in our circuits, and lab-grown BECs. We have covered the microscopic and the macroscopic.
We have covered a lot of ground.
But what happens when we push this nonlinear ocean to the absolute limit? What happens when a dying star exhausts its nuclear fuel and gravity causes it to collapse in on itself?
Well, under classical general relativity, the equations tell us we get a black hole. And at the exact center of that black hole, the classical math breaks down entirely into a singularity.
A geometric point of infinite density and zero volume.
Yes. The curvature of space-time becomes infinite.
A bottomless pit where physics basically throws its hands up and goes to die.
It is deeply problematic. General relativity essentially predicts its own downfall at the singularity. But under this electrodynamic fluid framework, space-time singularities are physically impossible.
They just don't exist.
Nature abhors infinities, and fluid dynamics simply does not allow for them.
If there is no bottomless singularity, what actually stops the collapse of the star? What is sitting at the center?
Gravitational collapse is eventually halted by a physical limit called the dielectric saturation of vacuum polarization.
Dielectric saturation.
To understand this, we have to reimagine the black hole entirely. The source papers redefine this ultimate cosmic object not as a hole, but as a superfluid soliton star.
A superfluid soliton star. Let's walk through the anatomy of this thing.
As the star collapses, The vacuum polarization gravity, those ponderomotive shocks and rogue waves, becomes unbelievably intense.
Because all that mass is getting crammed together.
Exactly. Under this extreme pressure, the subatomic particles making up the star can no longer maintain their spherical shape. They undergo what the theory calls a relativistic string transition.
Wait, strings, like an 11-dimensional string theory?
No, this is crucial to differentiate. This is not the abstract hidden dimension string theory.
Okay, good, because that always loses me.
This is grounded in physical phase transitions in 3D space. The core of this object is not a geometric point. It is a macroscopic, ultra-dense aggregate of one-dimensional physical strings residing in a melted Higgs-symmetric plasma phase.
Okay, that was a lot of adjectives. Basically, the immense pressure vaporizes the local vacuum boundaries that give particles their 3D shape.
Yes, melting them down into their fundamental one-dimensional topological string forms.
I want to make sure I grasp this terminology. What does a Higgs-symmetric plasma phase mean in this context?
Well, in the standard model, the Higgs field is what gives particles their mass by breaking symmetry. In this extreme high-pressure environment, that symmetry is restored.
Meaning they lose their mass.
The particles lose their standard mass characteristics and become pure, tensioned, topological lines of energy, the 1D strings swimming in an ultra-dense plasma state.
Okay, so the core is just a boiling ball of ultra-dense 1D strings in a plasma. What about the event horizon? Classically, that's the black sphere, the point of no return where not even light can escape.
In this framework, the event horizon is beautifully redefined. It isn't a magical geometric threshold in curved space. It is the optical boundary of infinite QED dielectric shielding.
Okay, dielectric shielding. Dielectric usually refers to insulators in electronics, things that don't conduct electricity. How does empty space act as an insulator at the edge of a collapsed star?
The vacuum is made of virtual particle-antiparticle pairs. Under extreme gravitational stress, these pairs align to shield the core from the outside universe. At the event horizon, this shielding becomes absolute.
So it's a perfect shield.
Yes. The dielectric contrast between the interior of the particle and the surrounding vacuum drops to zero. Because of this, the physical boundary of the string dissolves.
If the boundary of the string dissolves, where does all its quantum information and energy go? It can't just vanish.
The localized self-energy and the information of the particle is completely transferred to a highly polarized, two-dimensional superconducting vacuum boundary layer.
A 2D layer.
A sheath that tightly wraps the 1D string.
So the quantum information of the star that collapsed isn't lost in a singularity. It is smeared or encoded directly onto this 2D vacuum sheath inside the star.
Yes. Because auxiliary degrees of freedom are dynamically encoded on this 2D vacuum sheath, unitarity is completely preserved.
Unitarity being the fundamental rule in quantum mechanics that information cannot be destroyed.
Correct. This fluid dynamic approach elegantly resolves the famous black hole information paradox, and it does it entirely without the need for invoking extra hidden spatial dimensions or parallel universes.
The particle simply transitions from a localized 3D mass into a pure topological knot, a soliton of the vacuum electromagnetic field.
Exactly.
So a black hole is actually a highly structured, perfectly shielded quantum knot. It is a physical object supported by the absolute saturation limits of the vacuum itself. That is wild.
It is a profound rethinking of celestial mechanics.
But wait, classical black holes are supposed to slowly evaporate over trillions of years through Hawking radiation. Does this soliton star evaporate?
It does evaporate. But the mechanism for Hawking radiation is brilliantly updated to match this string model.
How so?
Well, in the classical model, Hawking radiation is explained by virtual particle pairs popping into existence exactly at the event horizon, with one falling in and the other escaping. It has always been a slightly clunky concept.
Yeah, it always sounded a bit like magic.
But here we have a boiling aggregate of physical 1D strings inside this plasma core. Occasionally, due to the intense, chaotic internal fluid dynamics, one of these 1D strings migrates to the outer surface boundary of the soliton star.
And what happens when a 1D string breaches the boundary and hits the normal vacuum outside?
When it breaches the boundary and enters the vastly lower pressure vacuum outside the star, it can no longer maintain its 1D string form. It undergoes isotropic decompression.
Meaning it expands equally in all directions.
Yes, it violently decompresses and snaps back into a 3D spherical particle.
It inflates like a specialized balloon popping into 3D space.
Exactly. And as it violently snaps back to a 3D sphere, it must release all of the stored transverse energy it held while it was a tensioned string.
How does it release it?
This energy is shed instantaneously as spontaneous fluorescence photons. But because of the specific geometry of a string decompressing, these aren't just random, messy thermal emissions. They are released as highly aligned anisotropic gamma ray bursts.
So the solid star is basically spitting out perfectly aligned, high-energy gamma rays as these strings pop back into normal 3D space.
Yes, and because this decompression is a deterministic physical process of the string reverting to its original state, the outgoing gamma rays perfectly preserve and transmit the quantum information that was encoded in the string back into the universe.
The information paradox is truly physically dead.
It is resolved without any hand-waving.
This entirely removes the magic from astrophysics. The universe doesn't have errors where math breaks down into infinity. We don't need hidden dimensions to hide our missing information. We can unify the cosmos under the rigorous, albeit intensely chaotic, rules of quantum fluid dynamics.
It replaces a universe of abstract geometric curves with a universe of physical interacting mechanisms. It is a universe where absolutely everything from a shivering electron to a supermassive black hole is connected through the turbulent, nonlinear medium we all share.
Let's pull back and recap the immense ground we have covered today.
It has been a journey.
We started with a tiny, isolated particle, just weakly breathing and shivering into the void. We watched how classical linear physics completely failed to carry that weak signal across the cosmos.
The distance transport problem.
Right. So to solve that, we embraced the chaos. We stepped into the nonlinear superfluid vacuum governed by the Vrbovsky-Banić equation.
And the NLSE?
Yeah. We saw how overlapping noise triggers modulation instability. We watched those microscopic signals mathematically snowball, stealing energy from the vacuum to spawn devastating 9x energy density peregrine solitons.
Vacuum rogue waves.
We redefined gravity itself from a smooth geometric curve to a violent statistical bombardment of mass boundaries via ponderomotive shocks, complete with intertwining tangles of quantized vortex tornadoes snapping planets together.
And we supported that theoretical model with real-world data. The 15-year stochastic low-frequency hum detected by nanograv.
The background noise of the universe.
Yes, the objective decoherence of macroscopic objects through rogue waves bombardment, the universal 1/f pink noise plaguing our precision circuits, and scale model analog rogue waves forming in lab-grown condensates.
And finally, we watched a dying star collapse, not into an impossible infinity, but into a superfluid soliton star. A beautiful, information-preserving quantum knot that evaporates by shooting anisotropic gamma rays as its internal 1D strings decompress. We have essentially dismantled and rebuilt the cosmos today.
It is a massive conceptual shift to process, but it offers a level of tangible physical intuition that abstract geometry sometimes lacks.
As we wrap up this deep dive, I want to leave you with a final provocative thought. We started by talking about the comforting, pristine image of the space-time trampoline. I want you to discard that entirely.
Oh, yeah.
If space is not an empty void, but a dense, turbulent ocean of energy that our atoms are actively negotiating with every single microsecond, what happens if we stop just passively enduring the storm?
That is the ultimate technological horizon. If gravity is simply a localized phase slip driven by nonlinear acoustic pressure, and if we can manipulate Bose-Einstein condensates in the lab to spawn rogue waves, it implies that gravity is not an untouchable fundamental force.
It's an engineering problem.
Exactly.
If you can engineer a localized phase slip, you aren't just being pummeled by the vacuum anymore. You could theoretically build a sail. You could surf the nonlinear waves of the vacuum rather than being anchored by them.
This staggering possibility.
It turns the empty space between the stars from a void to be crossed into an ocean to be navigated. Something to mull over the next time you look up at the night sky and think about the distances between us. Thank you for joining us on this deep dive into the chaotic heart of reality. Keep questioning the invisible forces around you.